let's look at valuing bonds with embedded options. In order to do that, we need to have an idea about how interest rates, or spot rates in particular, are going to emerge over time. So we've talked about what spot rates are. To find the spot rates, we look at market data. So here are 3 bonds. We're going to assume annual compounding just so we don't have to deal with the complexity of semi-annual. And then these 3 bonds, one matures in a year, one in 2 years, one in 3. Here are their coupon rates. Here's their market value in percent of par. So that means the spot rate, the 1-year spot rate, is going to be 8.163%. So that rate I know right here. I know that it's going to be 8.163%. What I don't know is a year from now, what will be the rate, the 1-year rate. It could go down, it could go up. So I'm going to need to find what those rates are. How do I do that? How do I come up with what those rates should be? Well, I know the price of the bond should be 98% of par. So I need to put in numbers that make this come back to 98% of par. And what I do know is at the end, in 2 years, so this represents 2 years, the value of the bond will be 100% of par. I'm assuming there's no default, so I'll get a payment of $100 plus 6.25 because that's what the coupon rate is. It doesn't matter if rates go up or down or stay the same. That's the payment I'm going to get at maturity. So then what if rates went down? What would I be able to sell that bond for? Well, the price of the bond would be, and the way this is going to be calibrated, I'm going to say there's a 50-50 chance of rates going up or down. Rates could go up and I would get 100 plus 6.25. Rates could go down and I would get 100 plus 6.25. So I'm going to get 106.25. I'm going to discount that back at this interest rate. And this interest rate I'm going to put in here is 4. I'm just guessing 4 for right now. And that 4% interest rates means the present value there is 102.163. In other words, if I did 106.25 divided by 1.04, I get that value right there. Okay, so the value at this point is the same thing, but it's divided by this interest rate. The value here is 50% chance of getting that payoff, the 101 plus the 6.25, and a 50% chance of getting this payoff, but that happens a year from now, so I discount it back at this rate, and I know that rate. So the question is, what should this rate be? Well, if I know this rate, this one is the lower rate times e to the 2 sigma. So I need to make some assumption here about the volatility of interest rates. So if interest rates had 0 volatility, then I would know exactly what that rate is going to be in the future. But I'm going to say they have 10% volatility because I've looked in past history, and that's my opinion, that we're going to have 10% volatility in interest rates. So what I need to do is go to Data, go to Solver, and I say I want to set this cell right here to a value of 96, because this is a 2-year bond, it's 96% coupon, by changing this. So I'm going to guess this rate, which will change that rate, which will change this value and this value, which in turn will change that value to be back to 96. Solve, and there we go. So now I know rate, the 1-year spot rate is currently 8.16. I'm saying it will either go up to 9.77 or down to 7.99. So I know that to be true. So I can come over here and say this rate will be 9.77, this rate will be 7.99. I got to go out one more year because I'm trying to value a 3-year bond. So the rate could go down to 7.99 and then up and then down. Or it could go up to 9.77, go up again, and go down. I need to choose these rates. This is at time 2, so here we are 2 years in. 2 years from now, what will the 1-year spot rate be? Well, I don't know, and I'm going to say rates could go down and down again, rates could go down and up, rates could go up and down, they could go up twice. So I have 3 possibilities for what the spot rate, the 1-year spot rate, will be 2 years from now. I need to pick this interest rate so that I will then know this one, which is e to the 2 sigma times that rate, which I'll know this one, which is e to the 2 sigma times that rate. So I know the relationship of those different rates, And I know the price of the bond at maturity in 3 years will be 100% of par. This is the cash flow that I'll get. So I need to choose this rate, which will change these two. These won't change, but it will change all the prices, and that price should go back to be 94% of par. So I go to Solver, and I want to set this target to a value of 94% of par by changing this cell. So now I have it. So now this is my interest rate tree. These are the possibilities of different interest rates, and it's calibrated to the market. So I know these rate trees back into the current market price of 94 for a 3-year bond, 96 for a 2-year bond. Now that I know those, I can come along and say, alright, what about a bond that has a coupon of 5.25% and it's callable at 100% of par? Now this is where you have to read the bond official statement very carefully, because bonds are callable at different rates at different times, so it could be callable at any point. So what I'm going to say here is this bond is callable at 100% of par, but not today. So I'm going to keep it like the original spreadsheet. It's not callable today at 100% of par, but it's callable at any of these times at 100% of par. So then would it be called? And for this one the answer is no, because I know the value at the end. If it goes to the end, it will pay me 105 1/4. So the value of that bond, if rates go down, and note this is rates going down, so this is the highest price of all of them, is 97% of par. I'm not going to call that bond at 97% of par. If rates go down, the value here is 94. I'm not going to buy this bond because that rate is so low. The coupon rate is so low, I'm not going to buy it. What if it had a coupon rate of 8%? Well, if it had a coupon rate of 8%, what would happen is it would be callable right here. And the reason for that is this: if it was not callable, I would just have the following. The price would be 100.142% of par. So that would be the value, but me as the issuer would know, hey, the thing is worth over 100% of par. I have the right to buy it back for 100% of par, so I will. So I include in Excel the statement that says, give me the minimum of either calculating the value with the formula or giving me the actual call value of the bond. So at each point, I check and see, is it above the par amount? So here it's not, right? That's 99. The calculated value is 99 because it has a 50% chance of getting this value, 50% chance of that value. If I move this to 8.5, it's callable here, it's callable there. And here I want to talk about this. In class I said, I meant to copy and paste and say, have the same formula with the min. But it depends. If the bond's callable today, yes, I want to have the function that looks like this. So if the bond's callable, I would want to have that min function there. If it's not callable, I don't. Alright, what about a puttable bond? A puttable bond gives me the right to put the bond back onto somebody else. So that sets a floor to the price. It's always going to be worth at least 100 and not set a ceiling like in the callable bond. So same procedure here, but you have max. Okay, so what I would expect you to be able to do is basically follow through this spreadsheet, and that's it.